Hello everyone, today I will introduce my paper. My paper topic is Design of Wireless Audio Real-Time Transmission Model based on Body Area Network Technology. Now look at my contents. I am introducing consists 4 parts. 1. Abstract. 2. Problem presentation. 3. Research ideas and processes. 4. Summary. Now look at 1. In order to achieve railway compression of audio signals and establish a more stable wireless network transmission model, this study designed a wireless audio real-time transmission model based on body-air network technology. First, with the support of wireless body-air network technology, a complete information aggregation processing system is built. And then the body area network environment is built by configuring the downloaded audio resource. Based on this, the digital signal process is selected and the complete data structure of multiple audio frames is established, so as to release the real-time transmission of waves audio. Experimental results show that, compared with traditional multi-channel audio transmission technology, the proposed model has higher effectiveness and stronger signal matching ability, which proves that it can compress the audio signal in real time and establish more stable waves network transmission environment at the same time. My paper's keywords are body area networks technology, waves audio, real-time transmission, configuration progress layers, resource download, resource configuration, signal process, protocol message. Now let's look at 2. All sounds that human beings can hear are called audio. For example, words, singing, music instrument. They can be proposed by digital music software, or it can be made into CD. If there is a computer audio cut, just we call it sound cut, we can record all songs in forms of computer hard disk files. Audio signals are the carriers of regular fractions and amplitude changes of sound waves with voice, music, and sound effects. According to the characteristics of sound waves, audio information can be classified into regular audio and irregular audio sound. Regular audio can be divided into voice, music, and sound effects. Regular audio is continuous change analogous signal, which can be represented by a continuous curve called sound waves. There are 3 elements of sound, include tones, intensity, and tempo. Body area network is a special wireless communication system which takes the device around the human body, such as watches, sensors, and mobile phones, and as well as used in internet human body. Therefore, in order to realize the real-time compression of audio signals and establish a more stable waves network transmission model, this study designed a wireless audio real-time transmission model based on volume domain network technology. 3. My paper includes 2 steps. 1. Build a complete information aggregation processing system by using wireless body area network system architecture, and then complete the construction of the body area network environment by configuring the downloaded audio resource. 2. The digital signal process is selected and processed according to the data structure of multiple audio frames. The smooth application of wireless audio real-time transmission model based on value domain network technology is realized. Now look at 1. Built body-air network environment. 1. Wireless body network system architecture. Wireless body divided into 3 levels, namely information collection layers, information aggregation process, and the cloud information layers. These 3 layers can connect and transfer data through Bluetooth and HTTP, and storage audio cloud layer. 2. Information aggregation process layers. Tier 1 is the information aggregation process layers. From this table, we can call Bluetooth name, include Bluetooth adapter class device, several socket and socket. When communication with Bluetooth model, we merely use Bluetooth adapter or Bluetooth device and Bluetooth socket class. Bluetooth adapter class is used to obtain the local waves audio, and so on. 3. Download and configure of audio resource. The audio resource application program is generally constructed by 4 function models: active object intention service and contents provide. 1. Activity. Activity is the most basic application component of body area network system. For example, the body area network system set 7 operation states for activity. For example, create, start, pause, resume, stop, resume, and destroy. These 7 different option states constitute the life cycle of each activity. 2. Intent. In order to release the job between different activities, the body area network system uses the intent component to complete communication between different activities, such as starting a new activity and pass data to a new activity. 3. Service. The main function provides some necessary support for activity service. 4. Content provider. A special data storage class and provides a set standard interface for obtaining and operating data. Contents provide also support data sharing, adding, querying, updating, and deleting options. 2. Wireless audio real-time transmission model. 1. Selection of digital signal processing. In my paper, I use TMS 320DM64. Also has 10100 internet interface. That means IEEE 882.3 standard eliminated the need of internet controller, thereby simplify security design and reducing security cost. 2. Message format of RTP or RTCP protect. RTP need RTCP to provide a guarantee for its quality of service. RTCP and RTP are all transmitted by UDP. Table 2 is the package of types of RTPC. For example, 200 data package is SR. Its purpose is audio sender report, and so on. 3. Audio frame data structure. Figure 2 is the audio frame data structure. This picture is from physical data link network transport session presentation application can provide a short delay, low cost, and higher precision solution. For example, session layers we can use RTP, transport layers we can use UDP, and so on. Figure 3 is structure of audio data package. For example, audio timestamps, audio message numbers, and channels, and CSC, and so on. 3. Model application ability detection. In order to verify the practice application values of various audio real-time transmission, the paper used two groups. One group is the experimental groups and the control groups. Among them, the experimental groups was equipped with wireless audio real-time transmission model based on body-air networks technology, where the control group was equipped with multi-channel audio transmission technology. In the same experimental environment, the specific change of the experimental indicator was analyzed. It is known that audio data transmission time can reflect the effectiveness of waveless audio information transmission. Table 3 is the compression of audio data transmission duration. From this table, we can see the PIS index can describe the real-time matching ability of waveless audio signal. Generally, the larger the PIS index value, the stronger on the real-time matching ability of waves audio signal and vice versa. Table 4 records the IQ changes in the PIS indicator of the experimental group and the control group. According to the analysis of Table 4, with the extension of experimental times, the PIS index of the experimental group keeps the trend of rising and falling alternately, and the global maximum reached 80.36%. The global maximum of PIS in the control group was only 48.54%, which decreased by the 31.82% compared with that in the experimental group. By comprehensive analysis of the above result, it can be seen that transmission computation of types of audio data is effectively controlled after the application of the model in this paper, and the values of PSR index also increase significantly, which proves that the model in this paper can realize real-way compression of audio signal with the established stable wireless networks transmission environment. The reason for the above result is that the model in this paper has an independent information aggregation process layer system which can establish a complete audio frame data structure, thus improve the PIS index and reduce the time consumption of transmission processing. For summary, compared with the multiplexed audio transmission technology, the wireless audio real-time transmission model designed in this study has an independent information aggregation process layer system supported by the value domain networks environment, which can realize the selection of digital signal process and establish the complete audio frame data structure at the same time. So from the practice point of view, after the application of model in this paper, the audio data transmission time is shortened and the PIS index value increases, which prove that the model in this paper can meet the real compressed requirements of audio signal more effectively and has a strong application and promotion significance. In the following research, we will consider enhance the anti-noise ability of the audio signal, use the model effectively transmit an audio data, so as to complete the further optimize also model. That's all my speech. Thank you.